Hello everyone, welcome back. This is Engineer Hussein Mosabi. So in this video we'll be looking at how to find the general term and the number. It depends with the terminology we use, depending what the number will be given, of a particular term of a geometric progression. Alright, so hopefully I expect most of us to have some basic knowledge on geometric progressions, which are mostly called GPs. But if not, don't worry. I'll try my best to make you understand. Alright, so before we begin, do not forget to like and subscribe. Alright, let's get to it. Now, when it comes to a geometric progression, there are certain things you need to understand. For instance, if at all we've been told to find the general term, so we need to understand that the general term is found by using the formula nth being equivalent to a open brackets r to the n minus 1. This is the formula we use for the general term or finding a number term, or the numbers of terms rather. So in this case, we need to understand that where n represents the number of terms, a represents basically what we call as the first term, and r in this case is called the common ratio. Now, the common ratio is basically found by, say, you have multiple terms, term 1, term 2, term 3, and it keeps on going just like that. To find the common ratio, all we do is to divide term 2 by term 1, which should be the same as 1 dividing term 3 by term 2. This should provide the common ratio. Now, let's try and put this to practice and see how best we can understand. Let's give a basic random example. Let's take, for instance, we've been given a GP. So let's say for the given GP, which represents geometric progression, let's say we have 6, 12, and 24. Let's say we've been asked to find, let's say, the nth term, which is basically something that can be termed to be the general term. To find the nth term, what we do in this particular case is just to use the nth formula, where we say nth is equal to a open brackets r to the power n minus 1. Now, since the general term, the value of n remains to be n, but the value of a is the first term 6, and the value of r should be what we get when we divide 12 by 6 or 24 by 12, which basically gives us 2 there and 2 there. So the ratio of these top values there are common, giving us the common ratio. Therefore, we're having our nth to be equivalent to 6 open parenthesis r to the, let's put the value of r there, so 2 to the n minus 1. Now basically we can leave our answer here, but it would be a bit unprofessional to do that. So let's just say nth is equal to 6, then let's apply the index properties. So this would be 2 to the n times 2 to the minus 1. Now in a case where we have the nth being equal to 6, then open parenthesis 2 to the n, then times 2 to the minus 1, we can always change this to 6, then 2 to the n divided by 2. Because now, having a negative power, say you have a to the minus n, this is the same as 1 over a to the n, like that. So basically, if I reduce this, we end up having 2 there, 1, but 2 into 6 as 3. Therefore, the nth in the particular geometric progression we have is basically 3, then 2 to the n, like that. Now, 2 to the n and 3 are not basically the same terms for us to say, okay, it's going to be 6 to the n. No, it's going to be wrong if we do that. But in this case, just like that, the way it is, gives us the final answer. So let's say we were told to find the fourth term. Now the fourth term in this case can be found using the particular formula that we have. We know the formula is nth being equal to a open brackets r to the n minus 1. We know that in this case n is equal to what? 4, because it's the number of terms we want to find, and we know that a is 6 and as well as r is particularly 2. So we say the fourth term is going to be 6, open brackets, 2 to the fourth minus 1, giving you 6. Then 2 to the power 3, giving us 6. 2 to the power 3 is basically 8. So this gives us 48 as our fourth term. If we want, we can use the general term we found to find the fourth term. So we could say, or since we have this general term, we can use it wherever there's n, let's put 4. So fourth is equal to 3, then 2 to the fourth, giving us 3, then 2 to the fourth will basically give us 16, and 16 by 3 is 48. And this gives us what we need for the fourth term. So you might be asked to find such questions, and you get it. Let me not say they're simple, but if you keep on practicing them, you'd find that they'll be not so challenging. Because in this aspect of this video, all I want us to understand is how to find the nth term. If at all somebody told you to say find the general term, or let's say the number term could be the fourth or the fifth or the seventh term, regardless of that. But now that we understand that basic approach, the next thing we'll look at will be deriving a certain aspect of a geometric progression. Alright, so if you have queries, you can reach me on the line 077 149 5252. Remember, slow progress is better than no progress. And this will just before becoming a statistic. Let's try and push for that A+.